ahead. We're going to solve this system. Right? You guys know how to solve this system 3 different ways so far. What are the 3 ways that you know how to solve this system?
The first way you taught us.
Excellent. What a great way. What are those ways?
Like inverse. Oh, wait.
This is from before the previous test.
Yep.
Here we go.
Substitution.
Substitution. That's one. Very good. Elimination. And there's a third one. The first one we did. Sometimes you can use a ruler if you want. Graphing. That's the third way. All right, looking for the intersection point. So that's 3 ways you know how to do this. All right, this is a 4th way, using matrices. So I'm going to first write the matrix equation. And how we're going to do that, if my pen works. Sad. So excited. I'm going to essentially take this system and rewrite it to be matrices, 3 different ones. Okay, let's see if this works. Yes. All right, here we go. Ready? So first thing I want you to do is to write a 2x2 matrix with just the coefficients of your variables. What are the coefficients of your variables? -6, 5, -5, and 3. So write down those in a 2x2 matrix. Do you guys see how I just pulled them from the system? Okay. Then you're going to write times, and then you're going to write a 2x1 matrix, so 2 rows, 1 column, that is called your variable matrix. What are the variables that I'm solving for? X and Y. Okay. Equals, and this is the constant matrix, another 2 row by 1 column matrix. What are the 2 numbers that are after the equal sign? Awesome. So this right here will get you a point when we take the test next week. All right, that's the setup. Any questions on the setup for this matrix equation? Okay, so now, after I do this, I'm now going to do some of the work that we did earlier this week and last week where we find the matrix inverse. So now I'm going to find the inverse of this first matrix, right, using that skill that you learned earlier this week, and then obviously you need to know how to find the determinant to do that. Once I find that, I'm going to use that inverse matrix to basically solve this, okay? So kind of go to the side. We can go underneath. That's fine. So underneath, I'm going to find the inverse of this matrix here. So I'm just going to call this a to the negative first power. Do you remember what that negative first power means? It's going to be the inverse. The inverse. Very good. All right. So that's 1 over the determinant. Do you guys remember how to find the determinant? Do you remember how to find the determinant of that matrix? Multiply diagonally. So what would it be? -6 times 3. Okay. And then what operation do we do? Minus. And then what's next? 5 times -5. Okay. What's -6 times 3? -18. All right. Minus a -25. If we're subtracting a negative, what is that really going to be? A positive. So what's a -18 plus 25? Positive. -18 plus 25. 25 minus 18. No, they're different signs. So you're going to subtract them. It'd be a +7 because the positive 25 is larger. Okay? So this is going to be times, and then do you guys remember what we do from earlier this week? Do you remember that phrase that I taught you? Switch ops. Look at you, Emmanuel. Switch ops. All right, so that first diagonal, they're going to switch places. So this is going to be 3 and -6. And what happens, bless you, to the 5 and the -5? What happens to that diagonal? They change the signs. Look at you. Very good. 5 and -5. Now, I know some of you might be thinking that those switch places, but I'll make sure you know, did the 5 and the -5 switch places? No. They became the opposite sign. All right? And where I put that determinant, I'm going to put 1/7. Okay? Everybody good? All right, at this point, what I'm going to do, all right, is I am going to write those as fractions. If you remember doing this earlier this week, the end of last week. So it's going to be 3/7, 5/7, -5/7, and -6/7. Okay, now I'm going to copy down my matrix equation, but watch what I put in front. So I'm going to put the 3/7, the 5/7, -5/7, -6/7. That's my inverse matrix. Now, what you're going to notice as I'm writing this, and I know you may not have different colors, but if you look at the different color selection that I chose, I essentially just copied what I wrote initially, but what did I put in front of each side of the equation? That inverse matrix. All right, so what that inverse matrix is going to do on the left side is it's going to basically, these are going to be inverses of each other, and when you multiply inverses of each other, you get 1, right? So this right here, and I can show you a little bit later if you'd like, but all this right here is going to end up basically just going away and leaving you with just the XY matrix. Okay, I'll repeat that. On the left side of the equation, this red matrix, that's the inverse, times this coefficient matrix, all of that is just going to become essentially what we call an identity matrix. All right, 1. And when you multiply 1 times X and Y, you get X and Y. Okay, so I'm not going to do any more work on the left side. I'm just going to bring down the X and the Y. Is everyone okay with that? I can show you later about what actually happens and why that's okay. But just trust me on that for now, and then I'll show you why that's okay. All right, so now the real work is going to be multiplying these two over here. Now, do you guys remember how we multiply matrices? Because we did this a couple of times. First thing you do is you write down the dimensions. What are the dimensions of my red matrix? 2 by 2. What are the dimensions of this matrix here? 2 by 1. Do you remember which numbers have to be the same? The inside numbers. So you underline the inside numbers. Are those numbers equal to each other? Are those numbers equal to each other? Yeah, they're both 2s, which means it is possible to multiply. And this number in front and the number at the end tells us the answer matrix. So the answer matrix, the dimensions are going to be a 2 by 1 matrix. Now I'm going to show my work because it's a lot of work here, and then I'll pass the calculators out so it can help you. All right, but essentially what I'm going to do is I'm going to have work to get 2 numbers. Okay, so I'm going to draw arrows to multiply the rows of the first matrix times the columns of the second. So like everything you've done with matrices to this point is now happening in this problem. Literally everything. Okay? So do you need me to use my fingers to show you where I'm starting? All right, ready? Okay, so I'm starting with the first number in the inverse matrix and the first number in my constant matrix. I'm going to multiply 3/7 times -2. So I'm going to write down 3/7 times -2 plus. Do you remember how to move with your fingers? So you're starting here, follow the arrows. So where am I moving in my first matrix?
To your right.
Excellent, to the -5/7. Where am I moving in my second matrix? There's only one place to go. Down, very good. So I'm going to multiply -5/7 times -1. Whatever that is going to be my first answer. That's going to be my X value. All right, I'm going to pause here. Remember, if you have a question, raise your hand and ask. This is not easy. Just take some time to figure out. Okay, now, using my fingers, all right, I'm going to move to the second row of my inverse matrix and go back to the first number in this constant matrix. So I'm multiplying 5/7 times -2. I'm going to write that down in my second row. All right, so 5/7 times -2.
It's always addition, right?
Always addition. Very good. Now, Gladys, what might happen, right? If you notice, this one does become positive. You're always going to write addition, Gladys. But if this ends up being like a positive times a negative, adding a negative is really subtraction. But I want you to always write addition. Okay? And I will be allowing you to use the calculators because I'm not testing your knowledge on multiplying or adding fractions in this section. That's not what this is about. It's about the matrices. Okay? So use your fingers. This is where I was. Where am I moving to? The negative 6/7 and then the negative 1. So I'm going to multiply negative 6/7 times negative 1. So whatever that is in my second row is going to be my y value. And this will be the hardest question on the test next week. Right? I anticipate this will be where the most points are missed. Just because it is so involved and it requires a lot of steps. All right? All right, so if you turn your calculator on, let's do the first one together. Turn your calculator on. Turn your calculator on, let's do the first one together. Okay, ready? So we're going to type in 3/7 times negative 2 plus negative 5/7 times negative 1. See if you guys get the same thing I do. I got negative 1/7. You did 1/7? Okay, so that is my answer for the x value. So right here, I'm going to write negative 1/7. Let's do the same thing for the y value. So the second row, I have 5/7 times negative 2 plus negative 6/7 times negative 1. I got negative 4/7. You guys did negative 4/7? Awesome. Now, I'm pretty sure in Delta Math, they're going to ask you for like the ordered pair. So when you write down the answer for the ordered pair, you're going to write down that first number, the negative 1/7. Come back. I need to get a new battery, clearly. Keep doing this. It's not going to last for much longer, right? Did you know that they make quadruple A batteries? They're so tiny. And when I found that out, I was like, that's so cute. So negative 1/7 and negative 4/7. So this is what you're going to type in to Delta Math, okay? How are we doing on that? That was a lot. I know it's a lot. It will be the most difficult question next week. But I also want you to know that you can do this, right? I know you can do this. We've been prepping for a while now. Everyone okay? It's going to be a lot, I know. When you're ready, go and flip to the back side. Let's do one more together, and then I'll let you guys practice on your own. No. I'm going to make the scoring of the test where if you don't know how to do this, you will not pass. Because it's the most important thing, because it uses all the stuff, determinants, inverse matrices. Like you're doing multiplication, you're literally doing everything. So it's like, what's the point of giving you a passing score if you can't do like the thing? Does that make sense? And it's not meant to, I'm not trying to be mean about it, right? You will be able to do retake. It's just I want to make sure you know that like this is the standard and you got to hit it. Okay? Yes. We already had our first test. I called it a test. It was short. This one will be longer. I think I'll make this one 2 days. I haven't decided yet, but I think I'm going to make it 2 days. That way there's enough time. Okay. What's the first step we're going to do in solving this question? The first step. I'm going to write down the matrix of the coefficients. I just want you to know the phrase is called write a matrix equation. That's what I need you to know. Write a matrix equation. So what is my first matrix going to be? Very good. 1.
Three.
-3.
Yeah, -3. -2.
And
9.
very good. What is the next matrix that I write?
The one that has the 3 and the 9.
No, I just wrote that one, the -3 and
Y.
X and Y. This is called the variable matrix. So the first one is called the coefficient matrix, and I can write these down if you want. Right, this is the coefficient matrix. This is the variable matrix. I'm not going to test you on those names. You don't have to write that down on the test. But if you hear me say that, you need to know what I'm referring to. So the coefficient matrix times the variable matrix equals, what's my last matrix? Very good. This one is called the constant matrix, the constant matrix. So that's the first thing. So Minerva, even if you don't know how to do the rest of the stuff, if you write that, let's get something, right? I probably still won't be enough to pass it, but ultimately that's kind of the first thing. If you don't write that, I don't feel good about your chances. All right? Now, after this, I'm going to find the inverse of the coefficient matrix. All right? The inverse of the coefficient matrix. So let's find the determinant of that matrix A, or the coefficient matrix. All right? So someone besides Emmanuel, what do I multiply first? No. It's the first diagonal. Remember the diagonal class? 1 and 9. Thank you, Donovan. And then what operation do I always use for the determinant? Subtraction. Very good. Samantha, do you know the next diagonal? And? Very good. Now, do I care, Samantha, if you wrote -2 and -3 as opposed to I wrote -3 and -2? Do I care? No, that doesn't matter. All right, so don't be like, it's okay. As long as you get the right diagonal first and the right diagonal second, and you subtract, you should be good. All right, so this is going to be 9 minus 6. 9 minus 6, so what is my determinant? It's 3. All right, so I'm going to put this 1/3 times. All right, and again, if you remember what Manny said, we're thinking switch ops, so switch places, opposite signs. So my first diagonal, 1 and 9, is going to switch places to become 9 and 1. My other diagonal, -3 and -2, those are going to become the opposite signs. So that's going to be a +3 and a +2. Now, that won't always be the case where all 4 numbers are now positive, but just know that it's always switch and then opposite. Switch places, opposite signs. Okay, so let's divide by 3. We actually can do a couple of these. What is 9 divided by 3? That's 3. What is 3 divided by 3? 1. But my second row of 2 and 1 are not divisible by 3. So I am going to write 2/3 and 1/3. Feel free, if you want to make it simpler, you could have written 9/3. You could have written 3/3. I don't care, because ultimately I just want to use this to then find the answer matrix. All right? So this right here, this matrix, is what I'm going to use to multiply by both sides of my matrix equation to essentially solve for my x and y. All right? So I'm going to write down that matrix that I just found called the inverse matrix. In front of my matrix equation. So I want your brain to think you're kind of writing the same thing you did at the beginning. You're just putting in front that matrix equation. Now, as you're finished writing this down, right, this is the work I want to see. Do I need you to do anything to the left side? No. Once I'm done with this problem, I'm going to stop the recording and show you up here what happens when you multiply all that out, because it's pretty tedious and cumbersome. But I want to show you one time of why we can just kind of forget about the left side. But what do I bring down on the left side? X and Y. All right. And then here, to get my answer matrix, I am going to show my work to find my 2 numbers. So multiplying the rows of this first one times the columns of the second one. All right, so Michael, I'm going to come to you first. Are you ready? So if I want to figure out what this x value is, what am I going to need to multiply to show my work here to find that answer? Go ahead, Michael. What do you think? Say numbers, please. 3.
And the 1/3.
No, do you need to? I'll show you with the fingers. Right. Start with the 3, which I like.
Oh yeah, 3 and -4.
Very good. 3 and -4. Hold on, let me write it down. Okay. Plus. Go ahead, Michael.
3 and 8.
Now remember, I like
-8.
that you move down here, but make sure you move over to there. Very good. So 1 times 8. Thank you, Michael. Let's go with Minerva. What am I going to write for the second row? My second row here. Times. Very good. Let me write that down. Plus, what's the last one?
1/3 and 8.
Very good, Minerva. Nice job. All right. Once I type this into the calculator, that will give me my x and my y values. The first one, I'm not going to use the calculator because it's all whole numbers. So that's -12 plus 8. -12 plus 8 is -4. My second one is going to be 2/3 times -4 plus 1/3 times 8. I got 0. What a day. Sorry for yelling. All right. So my solution that I'm typing in to Delta Math is -4, 0. All right. Pause. Yes, go ahead.